All right, go ahead and pull your calculators out for a second here. It says using your calculator to determine how many solutions there are for the equation cosine of 2x equals 1/2 from 0 to pi. So go ahead and I'm going to put it in radians, and I'm going to make my window go from 0 to 2 pi. And then go ahead and plug that in. Cosine of 2x equals 1/2. And then I'll plug it in here in a second. All right, so if I hit cosine 2x, and I went from 0 to 2 pi. Let me change so I can see it a little bit, my y min to -2, my y max to 2. All right, what do you do to see what it says cosine of 2x equals 1/2. How do I find where the solutions are, graphically? I got cosine of 2x graph. What else do I need to graph? Okay. Graph the second side of the equation. If you want to solve any equation graphing, you solve the left side, you graph the left side, you graph the right side, you just see where they intersect. So I go to y equals, I plug in 0.5, okay, and that's going to be a horizontal line. Well, how many places do those two lines cross, or those two curves intersect? 4. That's your answers. There are 4 answers, because what does the 2 do to our function? Okay, what does the 2 do to our function? Okay, do you recall? Joey, any ideas?
Does horizontally stretch it
Horizontally
or compress it?
Compress. So it changes the period. Yep. So it changes. So we get 2 full cycles from 0 to 2 pi as opposed to 1. That's why it hits at 4 points. Now you can find those decimals, but we need to find the exact values. Hold on here. Get rid of this stuff. Okay, so we know how many answers there are. All right, now let's go ahead and find those solutions. Now here's the case. Anytime you have a coefficient in front of your x, it's going to change the period, and it's going to change your number of answers. So cosine of 2x equals 1/2. I'm going to go back to that substitution. Anytime I have something other than x, I'm going to do this. I'm going to let theta equals 1/2. All right, here's kind of what we have to do in order to make sure we hit all the answers. Think about how we worded it for all solutions, or how we indicated it for all solutions. Okay, not just over an interval. So you get cosine of theta equals 1/2. And it might be a little bit easier if you kind of organize it the way I organize it on here. I'm going to kind of split it apart into 2 for this problem. All right, where does cosine of theta equals 1/2? It equals it at pi over 3, and where else? Okay. No, that would be a negative one. So it's got to be in quadrant 1. Okay, because 1/2 is here, so that means this is a 60-degree angle. So that's 60. Thank you. All right, Alex, at the end of the period. All right, 60 degrees, which is pi over 3, and the other one's going to be quadrant 4, which is 300. And so we got theta equals, all right, here's what we need to do. Theta equals pi over 3 plus 2 pi n. Let's go back to where we do for all solutions. And then the other answer is theta equals pi over 3. Not pi over 3, but 5 pi over 3. Plus 2 pi n. Okay, pi over 3 plus 2 pi over 2 pi n. Now go back and substitute in, what did we say theta was? No, why not let theta equal 1/2? You guys will probably look at me like I'm crazy. What should theta equal? 2x. Theta equals 2x. Go back and fix that, please. So now you get 2x equals pi over 3 plus 2 pi n. I'm going to do it over here. 2x equals 5 pi over 3 plus 2 pi n. All right, we want to solve for x. So technically, what do I need to do? Divide everything by 2. All right, so do that now. Divide everything by 2. And so that gives me, divide this by 2, this by 2, and this by 2. And that gives me x equals, well, pi over 3 divided by 2 is pi over 6. 2 pi n divided by 2 is going to be plus pi n. And then same thing over here. So x equals 5 pi over 6 plus pi n. All right, we need to find the solutions from where? We still need to find them over the interval from 0 to 2 pi. Since there's more than 2, and then because of that 2 is going to affect everything, here's what we do. Is basically we let n, starting with n equals 0, we plug in values until we get an answer that's bigger than 2 pi. So start like that. So let n equal 0, and I'm going to kind of work to the left and to the right. If n equals 0, pi times 0 is 0. You're left with pi over 6. That's one answer. Over here, you get 5 pi over 6. Those are both less than 2 pi. As long as you're less than 2 pi, then you got to plug in n equals 1. So I plug in 1. And then what does that give me? That gives me pi over 6 plus pi. Well, what does that equal? Pi over 6 plus pi. 7 pi over 6. And so over here we get 5 pi over 6 plus pi. Because you took pi times 1. And what does that give me? That gives me 6 over 11 pi over 6. So far I got 1, 2, 3, 4 answers. Now we know there's how many answers? We know there's 4, it's very solid. But here's what happens. So when you let n equal 2, I get x equals pi over 6, n equals 2 right here, plus 2 pi. Well, I should know right now it's going to be out of the range because 2 pi plus anything is going to be bigger than that. But that gives me 13 pi over 6. That is too big, so I don't include that. So here's all my answers. X equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, those would be my 4 answers. All right, when do we run into this situation? This situation occurs when you have a constant in front of your x is going to increase or decrease the number of solutions you usually have. Usually we only have 2 or sometimes 1, but you have to be careful. All right, we got the same thing going on here. Okay, same idea going on here. All right, still want the answer of the interval 0 to 2 pi. I don't wanna work in, before I do anything, I don't wanna work with cotangent. Make this tangent of 2x equals 3 over radical 3. What do we get when we rationalize that denominator? Okay, so just be careful there. So 3 over square root of 3. You get 3 square root of 3 over 3, but in the end, it just reduces to square root of 3. So I got tangent of 2x equals square root of 3. All right, now at this point here, let theta equal 2x. Substitute in, so you got tangent of theta equals square root of 3. All right, take a second and see if you can figure out what those angles are. Take a second, see if you can figure out what those angles are. Now it's positive, so it's going to be in quadrant 1 and quadrant 3. What you got?
So
What you got?
pi over 6 and 4 pi over 3.
All right, you got different reference angles there. I agree with 4 pi over 3. Pi over 6, I disagree with. Because what's your reference angle? 60 degrees.
So pi over 3.
So for that one, because if you do square root of 3 over 2 divided by 1/2, we'll get that square root of 3. So it's going to be pi over 3 and then 4 pi over 3. All right, what's the period for tangent? Do you remember? Amanda Kaiser, do you remember the period for tangent? Is it 2 pi or pi? It is pi. So here's what we're going to do. We're going to do theta. Our answer will be pi over 3 plus pi n. And our other answer was theta equals 4 pi over 3 plus pi n. All right, what's going to happen here with tangent? We talked about this earlier, but it's been a little while. What happens when you add pi over 3 and you add pi to it? What does it give you? Okay, what's pi over 3 plus pi equal? It equals, Andrew? Equals 4 pi over 3. So what happens, and we talked about this earlier, what happens with tangent and cotangent? Okay, these two kind of sets of answers are actually going to be what? They're going to be the same. They're just going to repeat each other. So we don't need to do the second set because it's already on there. All right? Only for tangent and cotangent. Okay, only for tangent and cotangent. Now I have this. Now I have to go back and substitute back in for theta. I got to let that equal 2x equals pi over 3 plus pi n. Divide everything by 2, and I get x equals pi over 6 plus pi over 2n. Now, so we don't miss any answers and we get it from 0 to 2 pi, start with n equals 0. Substitute in n equals 0, then n equals 1 until you get something bigger than 2 pi. We don't have to do both cases because that second one is really the same as the first one. Okay, for tangent and cotangent, they just overlap because the period is pi. All right, well, what do I get? And I'm actually going to do on the left-hand side, so I'm going to work in 1. N equals 0 gives me x equals pi over 6. N equals 1. I get x equals pi over 6 plus pi over 2. What is that? 3 pi over 6. 4 pi over 6, which reduces to 2 pi over 3. Okay, keep going because 2 pi over 3 is definitely less than 2 pi. So now multiply by 2, and I get x equals pi over 6 Plus, all right, pi over 2 times 2 is just going to give you pi. And what do I get there? 7 pi over 6? Hello. Keep going. Let n equal 3. And then I get x equals pi over 6 plus, when n is 3, pi over 2 times 3 is 3 pi over 2. And what am I going to end up with for that? Oh, that's what? 10 pi over 6? 5 pi over 3? Here, let me do something. Make this pi over 6 plus, that'll have a denominator of 6. 2 times 3, 3 times 3, 10 pi over 6, 5 pi over 3. And I'm going to do one more here because that's still underneath 2 pi, n equals 4. And hopefully you'll notice what's going on here. What is pi over 2 times 4? That ends up giving me 2 pi. So pi over 6 plus 2 pi. Hold on. And I get 13 pi over 6, which is too big. All right, so your 4 answers. What was the first one? Pi over 6, 2 pi over 3, 7 pi over 6, and 5 pi over 3 for that. Okay. All right, let's just do, we're just going to do this one more. 4 cosine 2 theta equals 3. All right, what's the interval it gives us? 0 to what? 360, so we need to be in degrees. We need to be in degrees. Divide by 4. You get 3/4. All right, now usually, depending on what variable they use, if they have a theta in here, I'm going to let x equal 2 theta. I'm going to let x equal 2 theta. And that gives me cosine of x equals 3/4. Well, is that a unit circle line? No. Use your calculator. Do inverse cosine equals 3/4. Okay. Inverse cosine equals 3/4. Emma, what do you get?
0.72.
I think you're in radians. Double check that. Go back to, convert back to degrees, and everybody else convert back to degrees for that. So, some trade equations. Yes. Doesn't get any better than that.
It's true.
For sure.
What time is this period over?
820. All right. Cosine x equals 3/4. What'd you get?
41.4.
So let's go. Here's what I want you to do. 41.4 plus, what is the period for cosine? In degrees. 360. So plus 360n. Okay, we should have a second answer for cosine. Your calculator doesn't give it to you because it's in which quadrant? We got your answer from quadrant 1. There's also an answer in quadrant 4. So that's your reference angle is 41.4. So take 360 minus 41.4. And it's 318.6. So we have a second answer of 318.6 plus 360n. All right, now we let x substitute in for 2 theta. Take your x out, put in 2 theta. Should be in here. So you got 2 theta equals 41.4 plus 360n. X equals, 2 theta. 2 theta equals 318.6 plus 360n. All right, what do I still need to do though? Okay, at this point, I still need to divide everything by 2 to get my answer right. So divide everything by 2. So I got theta equals, all right, 41.4, 20.7 plus 180n. Here, theta equals 318. Is it 159.8? Somebody confirm that.
1.3.
159.3 plus 180n. All right, according to the directions, I want all the answers between 0 and 360, not including 360. Since it's cosine, you have 2 different sets of answers. They do not overlap. Tangent and cotangent would overlap. So you start with n equals 0, and that means that theta would just be 20.7. And then over here, theta equals 159.3. Okay? Go to n equals 1. Figure out what you get there. So theta, you're substituting 1 into 180 times n, so it's plus 180, which will be 200.7. And then over here, theta will equal 159.3 plus 180. Oh, 339.3. All right, technically we keep going, but I think some of you will notice what happens when n equals 2. 180 times 2 is 360. It's automatically going to take you over that. So you get 20.7 plus 360, which is 387.7. Too big. List your 4 answers. What do we got? 20.7, 159.3, 200.7, and 339.3. Okay. All right, these are this is the first time we've done where you have a constant in front of that x that changes the number of answers we have to test by using the n equals 0, n equals 1, n equals 2 for that. Okay, page 681. Alex, you can go down to guidance.